Namaskar dosto, my name is Kalpajwal, you're watching Exercise Explained. So today we will be completely solving the first chapter of NCERT textbook, that is real numbers. In this video I am going to do the exercise 1.2 of it. So without any further delay, let's make your questions sound simple. Exercise 1.2, real numbers. Express each of the number as a product of its prime factors. So what we need to do is we need to show the factors of it, and we need to make sure that all the factors that we show are prime numbers. So for that, what we will do is we will write 140, as you can see I've written on the right side. So I divide 140 by 2, I get it as 70. Again, I divide 70 by 2, I get it as 35. I divide 35, now 35 is not divisible by 2. Let us try with 3. So with 3 also it is not possible because the sum of digits should be divisible by 3. I'll show you how that works out in the next problem or so. So 35 is definitely divisible by 5. So I divide it by 5. We get it. We get the quotient as 7. So 7 is also a prime number, so we can write it as 2 into 2 into 5 into 7. That's what I have written here. That is 2 into 2 into 5 into 7. So that can be written as 2 square into 5 into 7. Coming into the next question here. So the next question is going to be 156. So for 156, what we can do is we can write it as first we divide it by 2, and as we divide it by 2, what happens is I get quotient as 78. Now 78 is again divisible by 2. So I again divide 78 by 2, and what I get is 39. So as I get 39 here, now as I was telling you in the previous question, I would tell you that how you can find out whether a number is divisible by 3 or not. So we add both of this. So that is 3 plus 9 we added. So 3 plus 9 gives us 12. Now you know 12 is directly divisible by 3. So this 39 is definitely divisible by 3. I divide it by 3, I get the quotient as 13. Now 13 is again a prime number. So we can write 156 as 2 into 2 into 3 into 13. Which can also be written as 2 square into 3 into 13. Now you can see we are heading into slightly bigger numbers, 3825. Now 3825 can be divisible by 5. So when we divide by 5, we get the quotient as 765. Now this 765 is again divided by 5, and I get it as 153. Now I would check for 3. That is whether this number is divisible by 3 or not. So I just add all the digits, that is 1 plus 5 plus 3. Now 1 plus 5 gives me 6 plus 3 gives me 9. Now 9 is divisible by 3. That tells us 153 will also be divisible by 3, and we get it as 51. Now again we check 51 for 3. So 5 plus 1 gives us 6. So 6 is divisible by 3. So we divide it by 3. And once we get it 3 here, 3 into 17 times. Now 17 is a prime number. So we can write 3825 as 5 into 5 into 3 into 3 into 17. Which can also be written as 5 square into 3 square into 17. So getting into class 10's real numbers exercise 1.2 first questions, fourth one, that is 5005. So I divide 5005 divided by 5, so that gives me 1001. Now 1001 is definitely not divisible by 2. It is not divisible by 3 also, because sum of digits gives me 2, which is not divisible by 3. Next number is 5. It is not divisible by 5. Now I check for 7. So I check this for 7, and when I check it for 7, I basically get it is divisible, and I get the quotient as 143. Now 143 is not divisible by 7 also, it's not divisible by 3 also, it is not divisible by 2 also. So next what I have to check is I check for 11, and I get that 11 into 13 gives me 143. So we can write 5005 as 5 into 7 into 11 into 13. Coming to the next one, now this is going to be a pretty difficult one. Please remember this question, because if it comes in the exam, you'll spend a lot of time finding the prime factors of it. So 7429. So first number which can actually divide 7429 completely is 17. So by 17 when we divide, we get it as 437 times. Now 437 is not even divisible by 17. So that gets divided by 19 again. So when I divide by 19, I get it as 23 times. Now 23 is again a prime number. So we can write 7429 as 17 into 19 into 23. Remember, this is a very difficult question. In case you are not getting it, uh, leave it for the ending. Do not panic and waste time on this. So coming to the next question, that is for our NCERT textbooks real numbers chapter. Find the LCM and HCF of following pairs of integers and verify that LCM into HCF is equal to product of two numbers. So what we need to do is we need to find the LCM of these two numbers, that is 26 and 91. Then we need to find the HCF of these two numbers, and then what we have to do is we need to multiply this 26 and 91, and then whatever HCF we get and whatever LCM we get, we multiply those also and check whether both we get it as equal numbers. So let us get in here. So finding HCF, I use the Euclid's method, which I have done in the previous exercise. Almost all the problems from the previous exercise, that is real numbers exercise 1.1, are based on comfortable with Euclid's. So it says dividend is equal to divisor into quotient plus remainder. If you have not seen my previous video, do watch it. I will put the link in the description box below. So here I take 91 is equal to 26. So 91 becomes the dividend, 26 becomes the divisor. Now 26 into 3 gives us 78. When I subtract 78 from 91, I get it as 13. So this becomes the remainder. Now what I do is my divisor becomes the dividend. That means here I get dividend as 26, and this 13 which we had got here becomes the divisor. So 13 comes here. Now 13 clearly divides 26, that is 2 times. So we can write 26 is equal to 13 into 2 plus 0. So I can tell that this 13, that is the divisor, is the HCF of 26 and 91. Now we need to find the LCM. So for finding the LCM, what I would do is I wrote down the prime factors of 26. That happens to be 13 and 2. And for 91, I again wrote down the prime factors, which happens to be 13 and 7. So what we need to do here is whichever common term is there, we just write it once, and the other terms we just get it down as it is. That means you can see 26 is 13 into 2 and 91 is 13 into 7. So both the terms have 13 in common. So what I do is I get 13 down here into 2 comes down as it is, and 7 also comes down as it is. When I multiply all these three numbers, I get it as 182. That is going to be our LCM for 26 and 91. Now the question had asked us verify that LCM into HCF is equal to product of two numbers. So what I do is I multiply LCM and HCF, that happens to be 182 into 13. So that gives me 2366. Now what I do is I take the product of the two numbers which are given in the question, that is 26 and 91. So I multiply 26 and 91 and I get it as 2366. Now getting into the next question of our NCERT textbook, 510 and 92. So what happens here is, again I find the HCF by Euclid's. So I write 510 is equal to 92 into 5, that gives me 460. So I subtract 460 from 510, I get it as 50 here. Now what happens is 92 becomes the dividend, 50 becomes the divisor. So I can write 92 is equal to 50 into 1 plus 42. 92 minus 50 gives me 42. Now this 50 comes off here, 42 also comes here. So 50 is equal to 42 into 1 plus 8, because 50 minus 42 gives us 8. Now 42 comes as dividend, 8 comes as divisor. So 42 can be written as 8 into 5, that is 40. Now if I subtract 40 from 42, I get it as 2. So remainder becomes 2. Now I get this 8 as dividend and this 2 as divisor. So 2 into 4 gives us clearly 8. So we can tell that the HCF of 510 and 92 is 2. Now what we need to do is to find the LCM of the two numbers. So for finding LCM, I write down the prime factors for 510. So the prime factors for 510 happens to be 2 into 3 into 5 into 17, and for 92 it happens to be 2 into 2 into 23. Now as I told in the previous question, whichever term is repeating, we just write it once. You can see I have 2 here, I have 2 here as well. So out of these two 2's, I will get 1 2 down here and I would write this 2. And after that, rest of the terms, I just write it as it is. So 3 is here, 5 is here, 17 is here. Again, this 2 is here, 23 is here. When I multiply all these numbers, I get it as 23,460 to be the LCM of 510 and 92. Now what I need to do is product of 510 and 92, that happens to be 46,920. LCM into HCF, when I multiply, it happens to be 23,460 into 2, which again gives me 46,920. Next question of real numbers exercise 1.2, 336 and 54. So I would be taking out the LCM first. So what I do is I write the prime factors of 336, which happen to be 2 into 2 into 2 into 2 into 3 into 7. And for 54 it happens to be 2 into 3 into 3 into 3. So you can see here this 2 gets repeated in both the places. So we will write that only once. So I wrote it here. And this 3 also gets repeated once. So we can write the 3 here. So let's consider the last 3 to be repeated one, which is written only once. So rest of the things we would just write it as it is. So 2 into 2 into 2 is written here. Into 7 is written here. 3 into 3 is written here, and this 3 was the common one. So once we multiply everything here, we get it as 3024. Now we would be finding the HCF. So for finding HCF, again you can see I have used Euclid's, that is dividend is equal to divisor into quotient plus remainder. So that gives me 336 is equal to 54 into 6 times. So 54 into 6 uh, times gives us 324. So if we subtract 324 from 336, we get it as 12. So we write 12 as the remainder. Now, as usual, what happens is the divisor becomes the dividend. So 54 comes here and the remainder becomes the divisor and 12 comes here. Now 12 into 4 times, that is 48. So if we subtract 48 from 54, we get it as 6. Now what happens is this 12 comes off here and 6 comes here, and 6 into 2 times gives me 12 plus 0. So the divisor is going to be the HCF. So HCF we can write it as 6. Now what we need to find? We need to find the product of the two numbers. That means 336 into 54. So that gives me 18,144. Since the question had asked us to prove that product of LCM and HCF is equal to product of two numbers, what I do is I multiply LCM and HCF. Now HCF happens to be 6 and LCM happens to be 3024. So 3024 into 6 gives us 18,144 again. So you can see that product of the two numbers is equal to product of LCM and HCF. Now we will get into question number 3 of CBSE 10 standard real numbers, that is, find the LCM and HCF of the following integers by applying prime factorization method. Until now, in whichever questions I have done, I have used Euclid's for finding HCF. So here what I would be doing is I would be finding HCF by prime factorization. So the first question we have got here is 12, 15 and 21. So 12 can be written as 2 into 2 into 3, 15 can be written as 3 into 5 and 21 can be written as 7 into 3. Now whichever term is common in all these three, you can see 3 is there here, 3 is there here, 3 is there here also. So we can tell that HCF is 3. And LCM you already know, whichever term is common, we just write it once. I have written this 3 once. And whatever else is remaining, we just get it down. So 2 into 2 is written here, 5 is written here and 7 is written here. So after multiplying, we get the LCM as 420. So here we've got HCF as 3 and LCM as 420. Remember one thing here which is very important. If you do not have anything common between them, HCF is going to be 1. So getting into the next question, that is 17, 23 and 29. Now all these three are prime numbers, so they do not have any common factors except 1. So you can see I have written HCF is equal to 1. And LCM, we just multiply the three numbers, that is 17 into 23 into 29, that gives me 11,339. So let us get into the next question of real numbers, 8, 9 and 25. As you can see, I have already written the prime factors. 8 can be written as 2 into 2 into 2. 9 can be written as 3 into 3. 25 can be written as 5 into 5. So since they do not have anything in common, HCF is going to be 1. And LCM, what we would do is we would just multiply everything. So that is going to be 2 into 2 into 2 into 3 into 3 into 5 into 5. Or you can write 8 into 9 into 25. So that is 1800. So let us get into the fourth question of exercise 2.2 NCERT 10th standard. Given that HCF 306, 657 is equal to 9, find LCM of 306, 657. As you can see in question number 2, what we proved is product of two numbers is equal to product of LCM and HCF. So we will be using the same property here. So here HCF is given as 9. So first what we would do is we would be multiplying the two numbers, that is 306 and 657. So you can see here I have written HCF into LCM is equal to product of two numbers. So product of two numbers is written as 306 into 657, and HCF is written as 9 since it is given in the question, and LCM is written as it is. So LCM happens to be 306 into 657 divided by 9. As we cancel 306 by 9, we get it as 34, and the LCM what I get here is 22,338. Coming to question number 5 of exercise 2.2, real numbers. Check whether 6 to the power n can end with the digit 0 for any natural number n. So 6 can be written as a product of two prime factors, that is 2 into 3. So I would do that first. So you can see here 2 into 3 to the power of n is written as 6 to the power of n. Now since it is given end with digit 0 for any natural numbers, now if any number ends with 0, it has to be a multiple of 10. So we can consider 6 to the power of n as 10 into q. Now if we take the prime factors of 10, it happens to be 2 and 5, and q is written as it is. Now what happens? 6 is the prime factors of 6 are 2 and 3, but the prime factors of 10 are 2 and 5. You can see 2 is common, but 3 is not there, because you cannot have prime factor of 10 as 3, which basically contradicts the statement. So you can see here I have written 5 is a prime factor of 6 to the power of n, but this contradicts the fact that 6 to the power of n can have only 2 to the power of n and 3 to the power of n as factors. So we can say that 6 to the power of n cannot end with 0. Coming to question number 6 of real numbers exercise 1.2, explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. So you can see here I have already written what are composite numbers. These are nothing but positive integers which is not prime. So what we would do is from this number, that is 7 into 11 into 13 plus 13, we would take out 13 common, and when we take out 13 common, we are left with 7 into 11 into 1 plus 1. Now if I solve this, 7 into 11 into 1, so that is 77 I get, plus 1 gives me 78. So I write it as 78. Now what I do is I write down the prime factors of 78, which happens to be 2 into 3 into 13. And 13, since it is the prime factor, prime number, we do not have any other prime factors of it, so we write it as 13 only. So this can be written as 2 into 3 into 13 squares. So you can see here we have got, it has got prime factors, so it is a composite number. Coming into the next one, here the calculation is going to be slightly big. You can see we can take 5 common from both the places. Here also I have 5, you can see my mouse. Here also there's 5. So if I take 5 common, what I am left with is 7 into 6 into 4 into 3 into 2 into 1 plus 1. So if I multiply 7 into 6 into 4 into 3 into 2 into 1, I get it as 1008. And if I add 1 to it, I get it as 1009. So I've written here as 5 into 1009. So 1009 happens to be a prime number. So it has got prime factors, so it is composite. Coming to the last question of exercise 1.2 real numbers of CBSE 10th standard. There is a circular path along a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. So you can understand here that Ravi drives faster than Sonia. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? Remember, they both started from the same point, they're going in the same direction, but the thing is, Ravi is faster than Sonia. Ravi takes 12 minutes to complete one round, and Sonia takes 18 minutes to complete the same. So, in order to find when they will meet at the starting point again, we just need to find the LCM of 18 and 12. So what I do is, let us consider the meet after x minutes. So x will be the LCM of 18 and 12. So you can see I have written the prime factors of 18, that happens to be 2 into 3 into 3, and prime factors of 12, that happens to be 2 into 2 into 3. Now you can see here 2 is being repeated, 3 is being repeated. So I write 2 and 3 once, and this 3 is written here and this 2 is written here. So we get it as 36. LCM we get it as 36. So we can say that they meet again at 36 minutes. Now this part is not required for your question. I just wrote it to make things clear. In 36 minutes, the number of revolutions Sonia can do is going to be 36 divided by 18, that is 2 revolutions. And for Ravi, it is going to be 36 divided by 12, that is going to be 3 revolutions. So I hope you guys have understood the completely solved exercise 1.2 of real numbers. We would meet soon for exercise 1.3. Do share it with your friends and consider subscribing to the channel. Dhanyavad.